Okay. All right. All right, so this is the main thing. This is one of the two new things you need to look at, and that's when you have the expression e to the 2x. Basically, what this is, ladies and gentlemen, all right, e to the 2x is equivalent to e to the x squared. And basically, it's just like a quadratic. So this will factor like a quadratic into e to the x, e to the x. All right, you then look at c, which is 2. And you look for two numbers that go into 2 that in this case add up to -3. So that'd be -2 and -1. So you treat these, the e to the 2x, just like quadratics. And you factor it. The only difference is x squared, which becomes x, is replaced with e to the 2x, and just becomes e to the x. You then take each equation, all right, and solve it. E to the x minus 2 equals 0. E to the x equals 2. We've now isolated the exponential part. The inverse of e is the natural log. So we would do the natural log of both sides. The result, those would cancel, and we'd have x equals the natural log of 2. If it tells you to find exact, you leave it like that. If it tells you to estimate, you then go to your calculator and you do the natural log of 2, and I get 0.6931. All right, similar with the e to the x minus 1, e to the x equals 1. Again, I do the natural log of both sides. X becomes the natural log of 1, and the log or natural log of any number is 0. All right. E to the 2x minus 7 e to the x plus 12 equals 0. I look at my 12. That breaks down into 4 and 3. Those add up to 7. So that would become e to the x minus 4 equals 0. And e to the x minus 3 equals 0. All right. This would become e to the x equals 4. Do the natural log of both sides, which will cancel out the e. Get the natural log of 4. You would do the same thing there. And you would get the natural log of 3. All right. So basically for those, just make sure you're showing your factoring. Now, the one thing I would make you aware of. All right. So let's say you have another problem and you get e to the x plus 5 equals 0. All right. When you're doing this, so you solve for the e. So you get e to the x equals -5. You do the natural log of both sides. X equals the natural log of -5. Can't be done. We can't do a negative log. All right, so that is not a solution. So that, ladies and gentlemen, would be extraneous. So if you get a log of a negative, you have an extraneous solution. All right. So that's the one new thing and the centerpiece of the second homework that's due on Friday. You now have 2 posted homeworks due on Friday. The second one is 6 of these where you're just working on your factoring, and it's worth 10 points. Everything else is pretty much the same as yesterday. The natural log of 3x, the natural log is isolated. So we raise them both to a power of e. The e and the natural log cancel out, giving us 3x equals e squared. To get rid of a multiplication by 3, I divide by 3. And x equals e squared over 3 is the exact. If it tells you to estimate, you would go to your calculator, do e squared, and then divide that by 3. All right. If it's not isolated, you must do that first. So if I'm looking at 5 plus 2, natural log of x equals 4, I subtract 5. 2 natural log of x equals -1. Divide by 2. And the natural log of x equals -1/2. All right. Now remember, you can't do the natural log of a negative, but it can result in a negative. So we're going to raise both sides to a power of e. That'll cancel out the e in the natural log. And we got x equals e to the -1/2. All right. Please keep in mind, and we'll discuss this either tomorrow or Monday, there may be different forms of e to the -1/2. For example, if we turn it into a positive, that would be 1 over e to the +1/2. All right. If we write it as a square root, 1/2 is the same thing as a square root. So we'd have 1 over the square root of e. And if we rationalize the denominator, we'd have the square root of e over e. 7 plus 3, natural log x equals 5. So for those of you looking to show the bare minimum, you subtract 7 and then divide by 3. 5 minus 7 is -2. -2 divided by 3 is -2/3. So when I isolated it, it would be natural log of x equals -2/3. We would then raise both to a power of e. X equals e to the -2/3. Boom. It should estimate, you put in e and -2/3. Okay. Everybody good with that idea? If you do have questions, you can wait at the end of class and ask, or you can come back during either the office hour or virtual math lab today. Okay. Everybody good with those two? Going once, going twice. Okay. Last page, putting a coefficient in front of the variable shouldn't hurt much. All right, first move would be to divide by 2. So the log of base 5 of 3x equals 4 divided by 2, which is 2. Recall that now we're dealing with a log of a base, so instead of e, we will work with that base as an exponent. So we raise both to a power of 5. That will cancel out the 5 and the log 5. We'll be left with 3x equals 5 squared. 5 squared is 25. We would divide by 3, and x equals 25 divided by 3. Same thing here, divide by 3. Log 4, 6x equals 3. So we're isolating the logarithmic part. The base is 4, so now we're going to raise it to a power of 4, which will cancel out the 4 and the log 4, giving us not x, but 6x. Equals 4 to the third, 64. Divide both sides by 6 and reduce, and we get our final answer of 32/3. All right. So again, you want to isolate the variable and go from there. Everybody good? All right. So we go to the last thing of the day, which is using properties of logs like we talked about yesterday. So this is that last group on that worksheet. Okay, so you have to remember from the homework that was due last night, properties of logs. All right, and we're going to try to condense. All right, because if we condense, we're going to end up with a 1-to-1. They cancel out. We don't have to do inverses. All right, so you have to remember plus gets replaced with multiplication when we condense. Subtraction gets replaced with a division. And a coefficient gets replaced with an exponent. All right, and a coefficient gets replaced with an exponent. So I'm looking at this problem and I see two things. I have an addition and I have a coefficient. So that's going to become multiplication. So this becomes the natural log of x minus 2 times 2x minus 3. In the right-hand side, I'm going to move the 2 to be x squared. So that becomes the natural log of x squared. Now it's 1-to-1. I got one natural log there, one natural log there, so they cancel out. I'm going to distribute that or FOIL it, however you were taught way back in Algebra 1, 2x squared minus 7x plus 6 equals the x squared. I'm then going to get it in standard form, and x squared minus 7x plus 6 equals 0. Just like earlier with the e to the 2x ones, I'm going to factor x minus 6, x minus 1. And that makes my two solutions 6 and 1. However, you do need to plug back in. All right. You do need to plug back in. If I try 6, 6 minus 2 is 4. 6 times 2 is 12. 12 minus 3 is 9. And then that's also 6. So 6 is good. All right. So 6 works. Now I try 1. When I plug in 1, this becomes negative 1. This also becomes negative 1. I cannot have a negative 1 and do the log. Therefore, 1 is considered an extraneous solution. 1 is considered an extraneous solution. Okay? So with those, and they're at the bottom of the homework you were given yesterday that's due tomorrow, you got to plug back in to make sure it's not extraneous. All right, if you have a question after I'm done giving out these passcodes, feel free to log on. If not, once I give you your passcode, you are good to go. All right. All right. So we're going to start on the bottom. Like I said, once you get your code, all right, you are free to go. If you want to stay on, feel free to. Logan Soriano, KFC 93. Angel Santiago, LEM 81. Sebastian Rodriguez, FRO 77. All right, and you can enter either 0 or O. It's not going to matter. Ethan, MAP 22. All right. Catalina, FDR 32. Sarah, NHS 13. All right. Maura McGinty, CFS 16. CFS 16 for Maura. Ms. McCullough, ENS 11. Samantha Mall, JEB 99. Christopher, WDM 10. All right. Nicholas, CFS 04. Carly Izzo, EOB 18. Paul Healy, DDJ 96. Piper, JFK 72. Evan, RGW 21. Logan Darty, JSM 18. Camilla, AAG 99. Nicholas, HRC 16. Landon, AFH 92. Ryan, Austin, SDC 81. Once you have that, you're good to go. And we will see you tomorrow, either live or virtually. Stay safe, everybody, unless you have a question.
What are the codes for?
You're going to find out next week.
Okay.
Just write it down somewhere safe.
Have a nice day.
Have a good day.
Nice day. Have a good day, everybody. Stay safe.
I got a question.
Yes, sir.
You said Nicholas twice for the other Nicholas. I don't know which one's mine.
Okay, so you are the HRC 16 one.
HRC 16?
H as in Heckova, R as in Rottweiler, C as in Chili, and then the number is 16.
Thank you.
No problem, brother. Be safe.
Have a good day, man.
Yep.